Okay, so let's start. Okay, so today I will discuss the week 2 assignment of the course MM49 from the previous run. Okay, so let me open the PDF. Everyone can see my PDF, right? The assignment 2. Is it visible?
Yes, sir.
Okay, so let's start. So what is the first question? It's saying that fx equals to 2 by x square, which is defined on r minus 0. So we have to find the range of f. So what will be the range of f? Means what will be the image of f under,
Sir, the
yes,
screen is not visual, sir.
not visible.
No, sir.
Okay, let me share it then again. Okay, now can you see the assignment?
Yes, sir.
Okay,
Yes, sir.
okay. So what is the first question? It's saying that fx equals to, so given that f of x equals to 2 by x square, which is defined for x belongs to non-zero real number, right? You have to find the range of f. So how to find? Means you have to, you can also draw the diagram how this function will look like. So this, so at 0 it is not defined, right? It is defined from r minus 0. So what will be the value nearby 0? So when x is positive and very close to 0, what happens? So x tends to 0, this function goes to infinity, right? So plus infinity, so it will be look like at infinity. And what happens when x tends to infinity? This function goes to 0, so it will look like this, right? For the x positive, so it will goes to 0. So this is x, this is 0. And what happens when x goes to minus infinity? This function again goes to 0, right? And x tends to 0 from the left hand side, this again goes to infinity, so it will look like this. And this function will be symmetric, right, for around 0 for positive and negative. So this will be look like this. So this is the function f. So what is the range? Range means the image of f from for x in this region, right, without this 0. So at this function, can the function take the value 0? It cannot, right? At it can never be 0 function, right? Because as x tends to infinity, it goes to 0 asymptotically, not 0. So it cannot take the value 0, and it is always positive because it is x square and it's this function always positive. F of x is greater than 0, and fx is never 0, right? At x tends to infinity. So the range of f, what is the range of f? This 0 to infinity is the range, right? So the range of f is open 0. 0 is not included, and infinity. Oh, infinity is not a real number. So range is 0 comma infinity, right? So which option? So no options are correct. So all the options are incorrect here. If you understand this, so options are not correct. Everything is false. If this is open, then it will be true. So the range of f is open 0 infinity. Okay. Is it fine for everyone? Okay. So I move to the next question. So what is the next question? It's given that f of x is x square minus 9 by x minus 3. Yes? Any question? Yes. Okay. And what is g? G of x is x cube minus 27 by x minus 3, right? So note that these functions are not defined at 3. If x equals to 3, then it will be this function f and g are undefined, right? So x is not equals to 3 from here. Note x not equals to 3, right? And you have to find the limit as x tends to 3, means limit neighborhood of the 3. You have to find the limit of f plus g. And you know the property of limit, that if we property of f by the property of limit of addition, you know that this will be, you can write limit of f of x plus limit x tends to 3 g of x, right? So you have to find the limit individually. So let's first find the limit of fx. So what is this? Limit of x tends to 3 f of x. So what is the meaning of this? Limit x tends to 3, just write down the definition of f, x square minus 9 by x minus 3. Okay, so now you can factor the numerator, just factor it. It will be x plus 3 and x minus 3. Now here one question, can you cancel x minus 3? Can anybody say it? Can you cancel here or not? Yes. Can anybody say? Can you cancel or not x minus 3 from the numerator and denominator? If this is 0, then you cannot cancel, right? So you have to make sure that this x minus 3 is non-zero, then we can only cancel it out. But I am saying now that these functions are not defined at x equals to 3. So x is not equals to 3, means x minus 3 is non-zero, right? So we can cancel it out. So that's why we can write it as limit x tends to 3 x plus 3. Now you can, as x tends to 3, you can put, right? So what will be the value of the limit? It will be 6, right? Is it fine, the limit of fx? Okay. So now come to the limit of gx. It will be similar as fx. What will be the limit x tends to 3 g of x? Limit x tends to 3. What is g? X cube minus 27 by x minus 3, right? So as early factored the numerator. What is the factor? A cube minus b cube. I write down as a minus b into a square plus ab plus b square, right? By x minus 3. Again here x not equals to 3, so x minus 3 is non-zero, so we can cancel it out. So it will be x tends to 3 x square plus 3x plus 9, right? Now what will be the limit? So it will be 3 square means 9 plus 9 plus 9, so it will be 27, right? So then what will be the limit of f plus g? It will be just add up. So the limit of x tends to 3 f plus g of x, it will be limit x tends to 3 fx plus limit x tends to 3 g of x. So it will be, under the first one it's 6 plus 27. So what is this? This is 33, right? So we get limit of f plus g is 33 as x tends to 3. So which option is correct? So option 4 and D. Right? So this one is correct. So 33 is the answer. Is this fine? Any doubt? Question 2. Okay. Okay, now move to the question number 3. So you have to, yes. So now move to the question number 3. What it is saying that if x is given x for x belongs to minus 2 to 0 and f x equals to 4x for x belongs to 0 to 2. So you have to say f is continuous at 0, it is true or not, right? So fx, just write what is fx. Fx is x for x belongs to minus 2 less than x less than equals to 0, and it is 4x, right? If 0 less than x less than equals to 2, you have to check the continuity f at the point 0, right? So you can just take, okay, you can a priori see that as if x comes from the left hand side of 0, it will give the value 0, right? It will, because it's and left hand side it is x, and what is it is 4x, right? As so it, what is the curve look like if you draw it? So it is x, right? So x equals to minus 2, it will give the value minus, so this kind of, and when it is 4x, right? So it will be little bit like this. 2, it will be 4, means little bit steep. So if it is 2, it is minus 2. So you can visually see that it is continuous, right? If it is come from the left hand side, it is also give the 0, and right hand side it is also gives the 0. So you have to prove this. You have to prove this by epsilon delta. You can prove it, right? So what you have to prove? So for fix epsilon greater than 0, you have to find a delta such that what happen? Fx minus f0, right? 0 you have, at 0 you have to check the continuity. So you have to make this is epsilon in some small neighborhood of 0. So this you can, how you can write? So when x is less than 0, then what will be the fx? This is x, and f at 0 it is 0, and for positive it is 4x minus 0. So this is minus 2 less than x less than 0, and this is 0 less than x less than root 2, right? So just write it down again. What is this? So this is mod x for minus 2 less than x less than 0, and this is 4 mod x, right? For 0 less than x less than root 2. So you have to make this to be less than epsilon, right? So just this is the rough work. How do you choose the delta, right? So if you want this to be mod x less than epsilon, what will be the delta? You can choose delta to be epsilon, right? Then for mod x less than delta, this fx minus f0, which is mod x, it is also less than epsilon. So for the first one, delta equals to epsilon will work, and for the next one, what you will choose? So this you have to make this to be less than epsilon. So or which is, what is the meaning of this? So this is mean the mod x less than epsilon by 4. So you can choose this to be delta. So if mod x less than delta, then 4 mod x will be less than epsilon. Okay, so you have to make sure that both the things will work. So what will be the, you will choose the delta? Can someone, anybody say what you will choose the delta, so that both the things can make, you can make less than epsilon? Yes, can somebody say what will be the choice of delta, so that both you can make less than epsilon? So for the first one you get, this is delta equals to epsilon, and the second case you get delta equals to epsilon by 4, right? So choose the minimum of these two, right? Choose delta equals to minimum of these two, epsilon and epsilon by 4, right? So what happens then? If mod x, so if mod x less than epsilon delta, then what happens? Then mod x is automatically less than epsilon and less than epsilon by 4, right? So what happens then? then what happen, mod of fx minus f0, this is mod x. So this is because delta is less than epsilon, this is also less than epsilon. Okay. And when it is 4 mod x, so delta is also less than epsilon by 4, right? So this you can write 4 into epsilon by 4, means this is also less than epsilon, right? So in this region. So if you choose delta to be minimum of these two, then everything will work, right? So for this delta you will get this to be I, what you will get, mod of fx minus f0, this is less than epsilon. So this is the meaning that at 0 fx is continuous. So f is continuous at 0. Right? Is this fine? Any doubt with this? Any doubt with the question number 3? Continuity of f?
Sir, explain again, sir, please.
Okay. So you can see that this is continuous, right? By the graph also. This you can.
Yes, sir.
Yes. So you have to prove it by epsilon delta, right? So just write down what is the value of mod of fx minus f0. So when x is less than 0, fx is x, right? And f0 is 0. So just write x minus 0. And when x is greater than 0, so fx is 4x, so I write down fx is 4x, and f0 is again 0, so I write down it. So I just rewriting it. This is mod x and this is 4 mod x. Now you have to make this to be less than epsilon, right? Mod of fx minus f0. So when this mod x less than epsilon, so you have to choose some mod x less than delta, right? Because x minus 0 is mod x. So this delta and epsilon, if you choose delta to be epsilon, this will work. Whenever mod x less than delta, you can choose mod x to be less than epsilon. So for the first one, delta equals to epsilon will work. But for the next one, here it is 4 mod x. So that you have to make, when you want to make this to be less than epsilon, you have to choose mod x to be epsilon by 4, right? So delta you have to choose epsilon by 4. So for the second one, epsilon by 4 will work to make this to be less than epsilon. For the first one, epsilon will work, right? So if you choose the minimum of this epsilon and epsilon by 4, what is the minimum? So this is epsilon by 4, right? So if delta is less than this, then what happen? Then both the condition will satisfy, right? Delta is less than epsilon, also less than epsilon by 4. So when delta is less than epsilon, then mod x is less than delta, means this is also less than epsilon. So mod x is less than epsilon, first one we will get. And because delta is, for the second case, delta is less than x, mod x is less than delta, means it is also less than epsilon by 4, right? So for the second one I use the epsilon by 4, for the first one I use the epsilon, because this is minimum is epsilon by 4. So 4 cancel out, we get epsilon. So whatever in the region, if I choose this delta minimum of these two, then I get this fx minus f0 to be less than epsilon, right? So this is the meaning of continuity, right? What is the meaning of continuity at 0? What is the meaning at continuity at 0? Means you have to show mod of fx minus f0 to be less than epsilon whenever mod of x minus 0 less than delta, right? And this is the same as mod x less than delta. So that we will get, right? Do you understand? Pravan Kumar?
Yes, sir.
Okay. Okay, so now 3 is done. Let's move to the question number 4. What is the question number 4? So it's saying that consider the function fx equals to ln of square root of mod of x plus 1. Yeah, then you have to find the domain of f. right? So fx is ln of square root of mod of x plus 1. Domain of f means where fx is defined in so what is the option for the last one? So it is continuous at 0, means it's true, right? Okay, so it's true. The fourth one you have to say what is the domain of f, and where it is well defined, this function. So you have know that log is not defined at 0 and log is defined for, so ln is here not, ln is well defined for all x greater than 0, right? So this is square root of mod x plus 1, right? And square root is, and when the square root is well defined, 2 square root is well defined for all x greater than equals to 0, right? But if this mod x plus 1 is 0, then the log will not be well defined, right? So this should not be 0. So x cannot be minus 1, right? Because if x equals to minus 1, then the mod of x plus 1 will be 0. So if x equals to minus 1, then mod of x plus 1, this will be 0, imply ln is not well defined. So it cannot take the value minus 1. Suppose it is positive, means greater than minus 1 or positive. So what happens? This is a modulus, right? If it is except not minus 1, then the modulus is always positive, so square root is well defined. And the log, this is a positive square root, right? So log is always well defined. So it is only problem at the minus 1. So if x is not equals to minus 1, then mod of x minus 1, this is always positive, so square root is well defined, and this is a positive square root, so ln is always well defined. So this has only problem at minus 1, otherwise it is well defined. So what will be the domain? So domain of f, you can domain of f, so it will be whole R you can define except at the point minus 1, right? Because at minus 1 it will be 0, so log is not well defined. So what we will get? The domain of f is R minus 1. So this is minus 1, it is, so it will be R minus 1. So option 4 is correct, right? Is this fine? Okay. If it is fine, then let's move to the next question. Question number 5. What it is saying that if f r to r is a continuous function such that if r to r is a continuous function such that f of 9 is minus 1 and f of 10 is 1. So it is a function, it is defined on r, and it is 0. Suppose this is 9, this is 10. So at 9 the function takes the value minus 1. This is 9, this is 10. At 9 this function takes the value minus 1. So this is the minus 1, and at 10 these functions take the value plus 1, and function is continuous given, right? So if r to r, so this function, so you have to prove that then, so that then there always exists a x belongs to 9 comma 10 such that fx should be 0. You have to say it is true or false. So you know one property of continuous function, that intermediate value property, right? What is the intermediate value property? So suppose f is a function from a b to r or r to r. A b to r is a function and this is a continuous function, and if f of a is less than 0 and f of b is positive, then what it is saying, then there exists x belongs to a b such that, so it will be open a b such that f of x is 0, right? So this is the intermediate. So if it is take the value negative at 0 and positive at some point b, then it must cross the real axis, right? Here it is saying if it is continuous function and if it is 9 it is negative and 10 it is positive, because it is continuous it must cross some point the real axis, so it must take the value 0 at some point, right? Because this function is continuous. So this is the intermediate value property, so that you have to say, right? So this is true by the intermediate value property of the continuous function. So this is true by, so this is true. By IVP. This will, in short, we will write IVP. So we get some point in 9 and between 9 and 10 such that fx is 0, right? So this will be the point x. So this is true. Is this fine? The argument? Yes? Any doubt? And note that the function is defined overall. It can be anything. If it is take the negative and positive value, then it must cross in between the real axis. Okay. So if it is fine, then move to the next one. Question number 6. What it is saying? F is a function which is defined on r minus 0 to r. F of x is 1 by e to the power x. Note that at 0 e to the power x is 1, so it is not defined. So that's why its domain is r minus 0. So you have to find the range of f. So you have to just draw the functions, how it will, the function will look like, then you can easily find the range. So just what happen when x tends to 0 plus, because it is not defined. So just find what will the limit as x tends to 0 plus 1 by 1 minus e to the power x. You know x tends to 0 plus e to the power x. Where e to the power, this e to the power x tends to 0 plus, you know e to the power x goes to 1, right? And for if x is greater than 0, e to the power x is greater than 1. So 1 minus e to the power x is negative, right? So this will goes to minus infinity, right? Let me explain it again. What it is, as x tends to 0 plus limit e to the power x is 1 and e to the power x is greater than 1 for all x greater than 0, right? So that's why e to the power x for x greater positive, this is greater than 1, mean the overall it is negative, and as it is so overall negative and it will goes to 1, so that's why in the, so denominator goes to 0, mean the overall it will be goes to infinity, but as it is negative it will goes to minus infinity. So when it is 0 plus, so this side it is goes to minus infinity. And what happen when x tends to infinity? Limit x tends to infinity, where it will go 1 by 1 minus e to the power x. So as x tends to infinity, you know e to the power x goes to infinity. So overall so this will goes to infinity, means 1 by infinity is 0. So this is goes to 0, right? So this function will look like this, right? As x tends to infinity, it will goes to 0, and x tends to 0 plus, it will goes to minus infinity, right? So in the positive side it will look like this. Now check what happened is x tends to limit x tends to 0 minus 1 by e to the power minus x, and when x is less than 0, you know e to the power x is less than 1, so this is positive, and again x tends to 0, this 1 goes to 1, so it will be overall goes to denominator will goes to 0, means it will be infinity. But here it will be positive infinity because 1 minus e to the power x is positive, as 1 minus e to the power x is positive for all x less than 0. So that's why it is goes to infinity. So as x tends to 0 minus, it goes to infinity, and look at what happened when limit x tends to minus infinity, 1 minus e to the power x. As x tends to minus infinity, e to the power x goes to 0, right? So overall the function goes to 1. So as x tends to minus infinity, it goes to 1, and x tends to 0 minus, it goes to infinity. So how the function will look like? Suppose it is 1, so then it will look like this, right? And here it will be 1, it will be asymptotically, it will never touch the 1. And note that it cannot take the value in between 0 and 1. Why? So any number in the between 0 and 1, how you can write? So 1 by e to the power, so this 1 minus e to the power x. Suppose 1 minus e to the power x is some number which is s between 0 and 1, right? Then how you can write s? You can write 1 minus e to the power x, this is 1 by r, where r will be strictly greater than 1, right? So 0 and 1 I am saying. Or what happened? So then, what it will be? So r will be 1 minus e to the power x, means e to the power x is 1 minus r, and r is greater than 1. So what is mean? This is this side less than 0 as r greater than 1, right? But e to the power x is always positive, so which is a contradiction. Right? So 1 minus e to the power x cannot take the value 0 and 1. Right? So its values lying between minus infinity to open 0 and open 1 to infinity. Right? So what will be the range? So the range of f, so it will be minus infinity to 0 union 1 to infinity, right? So this is the curve, right? Is this fine? So which option is correct? Oh, I think all the answers are incorrect, so no options is that is correct. So range of f is will be this, minus infinity to 0 union 1 to infinity. Is this fine? Any doubt with this? Okay. So if this is fine, now move to the next question. What it is saying? F defined from open 0 1 to r, f of x. So f defined from open 0 1 to r, f of x equals to x square. Right? You have to find the minimum of f. Right? So how the x square functions look like? So x square function will look like this, but its given domain is given only the 0 0 1, right? So here you have to consider only, suppose this is 0, this is 1, and this is open 0. So you have to consider only this part. Here it is 1. So 0 is not there, so f cannot take the value 0, right? Because 0 is not there, so f cannot take the value 0, and 1 is not there, so f also cannot take. So minimum, because what will be the minimum? You can guess that 0 will be the minimum, right? But 0, f cannot take the value 0, right? Because at limit x tends to 0 plus f of x is 0, but f cannot take the value 0. Take the value 0, right? So whatever, because you can go as, if 0 is not there, you can go as small as you want, right? But 0 will never, so minimum is not, for f minimum will not exist, right? So this is the one property. For here the function is continuous, but note that the domain, it is open 0, right? It is not closed. So there is one theorem, if a continuous function on a compact set always attain the minimum and the maximum, but here it is open, so it is not closed, meaning it is not compact, so it does not have minimum. So f do not have minimum in 0 1, because at x tends to 0 it will goes to 0, but 0 is not the in the range of f, right? So f do not have the minimum, right? So minimum does not exist, right? Because you can, whatever, if fix any epsilon, you can always find a point for given any epsilon positive, you can always find an x such that x square is epsilon, right? So this is done in the class. Every positive number has a square root. So given any epsilon, you can always find a x such that x square will be epsilon. Mean you can, whatever positive number you want you get, but it can never take the value 0, because it is defined on open 0. So f does not have minimum, right? Is this fine? This one? Okay. So now move to the next question. Question number 8. What it is saying? Consider the set S 1 by n, where n belongs to natural number, union 1. You have to say this set is compact or not. Means compact, so this is a subset of R. So you have to show this compact means closed and bounded, right? So you have to, this set is bounded, right? Because S is bounded. You have to, so the what will be the last one? Okay, this I have done. You have to check this is compact or not. So closed and bounded. S is bounded. Yes, why? So how the points of the, so this is suppose this is 1. For n equals to 2, it will be half. So this is half. Then this is 1 by 3, 1 by 4. All the numbers, and here it is 0. 0 is not there, right? So all the number, so 0 is not there. Otherwise all number are there. So this set S, this is the set S. So S is contained in set, which set? Suppose this is, take this to be -1 and this to be 2. Then S is contained in -1, 2, right? So S is bounded, right? Because all the values of x, all the values lies between 2 and here, right? So S is bounded. means you can, so suppose, so if x belongs to S, then mod of x is less than 2 always, right? So this is the meaning of bounded. 2 is always the upper bound for S. Now you have to check this is closed or not. Closed means it has a, you can note that 0 is the limit point, right? Limit point means you can go as close as you want, because 1 by n is, if n is large, it will be very close to 0. So you can say that the 0 is the limit point of 1 by n, as 0 is the limit point of 1 by n. But 0 is not in this set, right? So what is the closed set? If all the limit points are in the set, then S will be closed. But 0 as is the limit point, and as 0 and 0 does not belongs to S, right? So S is not closed. So S is not closed. So this set is not closed, right? So means S is not compact. So S is not compact. So
Hello, sir.
Yes.
I have one question.
Yes, yes. So this,
If we include 0 in this set, yes,
yes.
then it become compact or not?
Yes, it will be compact. If you include 0, then you give the limit point, right? So the set becomes the closed, and it is bounded always. Do you get it?
Yes, sir. But
Yes.
I need another explanation in terms of every open cover has finite subcover.
Yes, yes.
It is.
Yes.
Can you explain in that way?
Yes. So you have to find a cover, right? So 1 by n. So every open cover has a finite subcover. So you can, so this, what is this? 0. This is 1. So this is 1. This is half. This is 1 by 3. So you can take this to be cover, right? Suppose this is, take the open cover. So this set. Suppose you constructed this cover O n. Here all the points are the open sets, right? 1 by n in this set. Discrete topology are its, right? Oh,
Yes, sir.
so here all the points are open set.
Yes, sir.
So, but this is a cover for this S, right? ONs are cover for S. This. But does it as a finite subcover? If you take only finitely many, then there will be many terms will be remain, right?
Yes, sir. So this will not compact.
Yeah, this will not compact, right?
But in our actual definition, when the limit point, if limit point is included,
Yes.
then that set will become bounded and the closed, right?
Yes. Yes. Yes.
That should be the compact, na?
Yes. So yeah, what you have to take? You have to take the cover, right? So what will be the cover? So around 0, you can take. Oh no, but oh, okay. I think here you have to take the cover in R, right? It, not the discrete
Yes.
topology. What you, so here you have to take this cover, not this cover. You can take this cover, open 0 and 1 by n. This cover, ON. So this is open cover, right?
Yes, sir.
This is open cover. ON is a cover for S. Cover for S. Does it has a finite subcover?
Yes.
Hmm?
Yes, I can it. Yes, yes, sir.
No, in S. In S. In S it does not have, right? If you have only finitely, sorry, what I am saying? No, you have to take, sorry, I have missed it. Just take the other way. 1 by n and comma 1. This cover. 1, union 1, right?
Yes, sir.
and take other cover half comma union this half comma 2. This is open cover of S, right? Does it has a finite subcover? Because if it is finite, then the sum 1 by n will always be remain, right? In S, that you cannot cover. So it does not have finite subcover. Finite subcover. So now what you are saying, if you include the 0, so then what happen? Now suppose define S tilde. So this is 1 by n belongs to n, union 0, 1 is there. So then is this cover will work? This cover will not work, right?
This, yes, sir. This
So you have
cover
to
will
take
not.
some cover around 0. If you, as soon as you take some cover around 0, it will contain infinitely many of 1 by n. And for the remaining you can take the finite, right?
Yes, sir.
Did you get? So S tilde has a finite subcover. So S tilde for any open cover. So S tilde is compact, right?
Yes, sir.
So this is other way or something different. Is it fine for everyone? So for the this one S is not compact, so this is false. Is it fine for everyone? Okay. So now move to the next one. What it is saying, the complement of the set of rational numbers in R is, it is open, closed, bounded, and none of the above. So in R, what is the so this is, you know, this is Q union R minus Q, right? So what is the Q complement? This is irrational number. Is this open? Set of irrational number, is this open? Can anybody say? This is not open, right? First one, R minus Q is not open. Why? Because if you take some point and take a open interval, there will be because rational numbers are dense, there will be always a rational numbers. If suppose if x naught belongs to R minus Q, and if you take x naught minus delta x naught plus delta, there you can always find a R which is R, where R is rational, right? Because rationals are dense. So R minus Q is not open. Is it closed? R minus Q? Can anybody say it? Is R minus Q closed? Means what you do? You have to say that all the limits points are there, right? But you can always find a sequence xn which is R minus Q such that xn will converges to a real number, or rational number, right? So R is a limit point of the sequence of irrational number, but R is not a irrational number. So xn is this is not closed, right? So R minus Q is not closed also. Is it bounded? Is irrational number bounded? No, right? You can always find some square root n which is not a, where n is square free, right? So this will square then this will give the irrational number, right? And this is unbounded, right? And this will be irrational number. So this is not bounded. So what will be the answer? So the irrational number set, so it will not open, not closed, not bounded. So it will be none of the above. So not bounded. Is this fine? Yes. Okay. So if it is fine, now move to the last question. What is saying? If x is given 1 by x minus 1 and 2 minus x, and x belongs to, note that there is some problem. At the point 1 and 2, this function is not well defined, right? So I think it's a little bit wrong in the question, because you have to check that fx satisfies the Rolle's theorem or not. So it is not defined at the point 1 and 2, right? So you cannot talk about this. So Rolle's theorem is, it will not be applicable, right? You have, for the Rolle's theorem, you have to define, for Rolle's theorem, the function f should define at 1 and 2, right? And it should be equal, right? But here it is not undefined. At the point 1, it's infinity, it is not real number. So as f is undefined at 1 and 2, so Rolle's theorem is not applicable. Right? So this is a false. Rolle's theorem you cannot apply. But you can little bit modify, because this function is only problem at the 1 and 2. Then it will be, you can apply the Rolle's theorem, right? So just consider this function. So this is some difference. So this answer is done. So now consider fx 1 by x minus 1 and 2 minus x. So just take this, x belongs to, just because at the point 1 it is not defined, you make a little shift, 1 plus epsilon and 2 minus epsilon for epsilon positive. Then this function is defined, right? So now you can check the Rolle's theorem is applicable or not. And this is in this is continuous. Then what happens? F at 1 plus epsilon, what will be the value? So it will be epsilon into 1 minus epsilon minus 1 minus epsilon, right? Yes. And what will be the value at 2 minus epsilon? So it will be the value 1 minus epsilon and it will be epsilon. So these two are same, right? F of 1 plus epsilon is same as f of 2 minus epsilon. And this is a continuous. You can check that f is continuous on this 1 plus epsilon 2 minus epsilon, and it is also differentiable on this opening. So Rolle's theorem now is applicable. So now Rolle's theorem applicable. So then you can say that there will exist a x between this 1 plus epsilon and 2 minus epsilon such that f dash x will be 0. So look at the curve, how it look like. So if this is this at 1 and 2, because at this point these are not defined, so asymptotically this curve will look, this function will look like this. So whenever you make 1 plus epsilon and 2 minus epsilon, so this function here it will be well defined. And now you can apply the Rolle's theorem. Yes. So here it will be, and you can always find x such that a derivative will be 0. So this will be the function in the region 1 plus epsilon and 1 2 minus epsilon. So there you can apply, but in the region what is given in the question you cannot apply. So the answer is false. Okay, so all the questions are done. Any question? If there is any question, then I can discuss. Yes. Is it fine for everyone? Okay, if there is no question, then we can end the meeting for today. We will meet the next week. Okay, thank you. Bye, everyone. Yeah, thank you. Thank you, everyone.